Hello, geometry. We're doing 10-7 today, area of circles and sectors. Again, a reminder, I think you know this, but the area of a circle is pi r squared. So just a quick reminder there. So if we were trying to get an area of a sector is just part of the circle, like that. So you can probably guess what we're going to do here. We're again going to take the measure of the arc. So how much of the arc are we talking about? How much of this circle? So a circle has a radius of 4 inches. What is the area of the sector bounded by a 45-degree minor arc? Okay, so you have a circle, you have a 45-degree arc, and you want to figure out the area bound by that arc. So this right here. Okay, so you are going to, again, we have to find out how much of the circle that is, what percent. So you're going to take the 45 out of 360 degrees, and you're going to multiply it by the, in this case, area. Yesterday it was circumference. So pi times the radius, which is 4 squared. Okay, so 45 over 360, they can divide by 45 and you get 1/8 times pi times 16. And that's slick because that simplifies to 2 pi. Don't leave your answers in terms of pi. So we're not going to multiply that out, and we're going to put the unit, which is inches. And it is area, so it is squared. So pretty straightforward, kind of similar to yesterday. This next part's a little different because it doesn't really, the term segment of a circle makes you think of just a segment, but it's actually a part of the circle bounded. And that means those are the boundaries, bounded by an arc and a segment joining its endpoints. So we have the arc, okay, and then we have a segment joining those endpoints of the arc. And the segment of the circle is everything then in between those two boundaries. Okay, so first you need to understand that piece. Now, in order to get the area of such a piece like that, you need to get the area of the whole sector first. Okay, then you're going to subtract the area of this triangle out of it, and what you'll be left with is, of course, what you need, which is the area of the segment. Okay, so let's give it a shot. What's the area of the shaded segment? Okay, so we need the area of the sector first. We're going to subtract the area of the triangle next, and we're going to be left with the area of the segment. Okay, so the area of the sector. So we need to know the degree measure here. The degree measure for this whole thing is 90 degrees over 360 times the area. Pi times radius squared. So I'm just going to work with this first before I move along. So 90 over 160 is 1/4 times pi times 16. The 4 and the 16 cross off, and you're left with 4 pi for the area of the sector. Now we need to subtract the area of the triangle. So we are going to use our formula, 1/2 base times height for the triangle. And the base and the height are both 4. And I end up with 1/2 of 16, which is 8. And that is, does it say to leave? Oh, it does say to round. So we have 4 pi minus 8. So you would need to do 4 times pi minus 8, and you should check it with your own calculator, get 4.6 meters. Again, it's area squared. And that would be the area of this part right here, because I took the whole big thing and I subtracted away this triangle. So then I was left with just this part. All right, boys, hope that helps. Hang in there. Bye-bye.